Yeah. So I have planned some very simple paper folding based activities. Um, so I usually do it with primary and middle school children. Um, Starting with an A4, you can cut it into half and start with a A5, but I will just do with A4. So now the task is to fold this. I think Ashwin, this part we've seen this before. You will fold it in such a way that you will get 8 equal rectangles when you open it. Fold it in such a way that you will get 8 equal rectangles when you open it. So just to short circuit things, there are two ways to do it, right? So we will go for the 2 rows option. So once you fold it, you'll get this. There are 2 faces. Color one face. Color or write your name or whatever. Just mark one face. So if I were to number these rectangles as 1, 2, 3, 4, 5, 6, 7, 8. So can you guess which is the rectangle that you've colored? Have you colored rectangle 1 or 2 or 3 or 4? Which of them have you colored? Without opening, make a guess, and then you can open it and see whether your guess is right.
My guess is 2 and 3 or 6 and 7.
Okay, by rotating, it could be any of them.
This is my guess.
Right. Okay. Preeti, how about you? What was your guess? Did it turn out to be right?
I'm so bad at imagining it. I'm still trying folding it.
Your time, take your time.
Is it 3 or?
It depends on how you did it. So we might not all get the same rectangle.
Are we supposed to like cover both the sides?
No, color only one side.
Oh, okay.
No, I was wrong. It turned out to be, yeah, 3 or 7. Okay.
Okay.
3 or 7. Okay.
Okay. By rotating, it could be 3 or it can't be 3 or 7, right? Because
2, 2. Yeah.
2 or 7
2
or
or
3 or 6, depending on which one you
Two
color.
or 7.
Right. Cool. So this is just like a warm-up. Now what we'll do is we will number the rectangles the way it is on the screen.
Okay.
So I will write 1, 2, 3, 4, 5, 6, 7, 8. And at the back, I will write the same numbers. So behind 1, it should be 1 only.
Okay.
And behind 2, it should be 2 only.
Okay.
You will get it kind of in reverse here. And just to be able to tell it apart, we'll put an underline. So we'll write 1, 2, 3, 4 with underline. And 5 would then start here. 5 is here. So we will write 5 here. 6, 7, and 8. So now the question is, you have to fold this up to make this smallest smallest package, right? And you can only fold along the existing folds. So you cannot, for example, you can't make cross folds like this, or you cannot make a fold here. All that is not allowed. So you have to fold it like this only. So now the question is, when you fold it, are all the combinations possible? So for example, can you do 1 in the front and 2 at the back? So you should have 1 at the front and 2 at the back. So now, can you fold it such that you'll get 1 in the front, 2 at the back? Yes, that's very easy. We can do 1 at the front, 2 at the back. What about 1 at the front, 3 at the back, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 2, 3, 2, 4, 2, 5, 2, 6. What combinations are possible? What combinations are not possible? Are there any that are not possible? So that's the exploration. So another thing is we don't have to worry about front or back. So if you get the 1 from the front and the 3 from the back, it's okay. Done, right? Okay, 1 and 2 is done, 1 and 5 is done. Now let's try everything. 1, 3, 1, 4, 1, 6, 1, 7, 1, 8. Okay, I think
Got
1,
1 and 4.
1 and 4 is done. So can you describe how you did it?
I just folded it into half first.
Folded it into half.
Half.
Okay.
And then did that accordion fold.
Okay.
So 1, 4.
Okay. Nice. So do you think this would be a unique way to get it, or would there be more ways to get it?
So both the numbers are at the top row. So I think there should be only one way I can fold it and get it.
So I'll just start tabulating now what all we have done and what all we need to try. So 1, 2 we were able to do. 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. 1, 5 is done, right? 1, 4 is also done.
1, 3 is also done. I'm not getting 1, 3.
Nobody has shown 1, 3 so far.
I got 1, 2, 1, 5.
Ah.
I tried only those two.
So then what are the other combinations we can try? Something with 2 in the front. So we don't need to try 2, 1 because we've already done 1, 2. So 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Then 3, 4, 3, 5, 3, 6, 3, 7, 3,
5,
8.
8 is possible.
Sorry?
5, 8.
5, 8. Oh, okay. I have not yet written that. Let me write. 4,
5, 6.
4, 6, 4, 7, 4, 8, 5, 6. 5, 6 you said is done, no?
Yes, for me.
5, 8. Then we have
I got 1, 3.
1, 3. Oh, wait, let me spotlight you and you can just let me finish writing this. 6, 7. Then we have 7, 8. Okay.
So what I did was I folded 1 front and 1 back like this and 1 back.
Okay.
And then I folded it into, so now I have 1 and 3 on the same side. That is 1 from the back side and 3 in the
Hmm.
one, but both are on the same side.
Right.
And then I just folded it into half
Hmm.
and then again folded it.
Nice.
So 1 and
Right.
I did it other way.
Oh, is it?
Yeah.
Wait, I will just spotlight you. Yeah.
I don't know whether that was similar, but I just tried to bring this 1 and 3 together.
Hmm.
Then folded this
Hmm.
and then
Oh, okay. Slightly different. The first step was same, but then it was slightly different. So now we have more than one way to get the same configuration of front and back. Oh, nice. Right. So at this point, usually while doing with students, children struggle to explain how they're doing it. Like uh, they will come up with something. Then when I ask them to show, they will not be able to show it. Right. So at this point, I use this to bring in like the need for some conventions, notations. So if we have to develop a language to express these folds, what can we do? How can we come up with a notation for these folds? So that we can quickly say blah, 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 and we can all get basically reproduce the fold exactly. How can we do that?
1, 3 is possible, 5, 7 is possible, the same way.
1, 3 and 5, 7. 1, 3.
5, 7. 1,
Five.
2. If 1, 2 is possible, then same with 5, 6 and all. Means the numbers, those are next to
Ah,
each other.
very nice. So 5, 6, 7, 8,
Yeah, 7, 8,
3, 4,
even 5, 7.
5, 7. Oh, because we can do 1, 3, we can do 5, 7.
Yes.
Ah, okay. Because okay, we've already ticked off 5, 7. What else? Can we also tick off 2, 4 then? Because it's similar.
We can also tick off numbers that are right below each other, right? 4, 8,
4, 8,
7.
2, 6, 3, 7. Right. And because 1, 4 is possible, 5, 8 should also be possible.
Yeah. Yeah, 5, 8 is also possible.
Right. So we are left with a few to check. 2, 3 is done because it's adjacent. 4, 4, 5 is interesting.
So numbers with one gap in between them, we just do the front fold, back fold, and so 2 and 4, you can get it just like 1 and 3. So one back fold, one front fold, so that they are together, and then fold it into half.
No, not clear. Say it again, Preeti.
That is what you did for 1, 3, Shubhangi, the same thing, similar.
Yes, but now I'm not getting.
So 2 and 4 have one gap between them, right?
Right.
So you make one back fold so that 2 is visible. And then you bring the 4 front,
Okay.
then fold it into half. Then
No, but then bring 4 where? See, I folded 1 at the back of 2.
yeah, and 4 you bring it to the front of 3.
Oh, okay. No, but how can I do that?
Okay,
How-
so at this point, can we spend 2 minutes trying to think of how we can use notation for this?
Notation. So flipping, I
Yes,
think.
I got it. I got
uh,
2 and 4.
So
I
2
think
and 4 is done.
that one number is from the back side, 2 is from the back
Yeah,
side, 4 is
yeah,
from the front side, right?
yeah.
Okay. Oh, that's the key.
So is there a pattern in that also when we get numbers on the same side or numbers from the front and back?
Back, huh? Yeah.
If it's alternate, we are getting back.
Right.
Okay. So here is something I could think of for notation. So there are basically 4 folds here. So this is fold 1, this is fold 2, this is fold 3, and this I will call as fold 4.
Okay.
And each fold, you can either do it towards the front, that is where the numbers with don't have underline. So you can either fold it towards the front or you can fold it towards the back so that the numbers with the underline will touch. So even after making say one fold, so this is my first fold. Now the second fold, let's say I want to make this F4. So I can either fold it forwards or backwards. So maybe we can call it F4 for folding forward and F4 dash for folding backwards. Or let's say I will now do F3. So F3, I can either bend it forward for F3 or fold it backwards, F3 dash. Of course, I don't have to use the right flap to fold it. I could do this, but these are equivalent. So, oh, I got 180. Okay, I will try to describe it with the notation. So F1, then F4 dash, that is F4 backwards. And then F3, and then F2 dash. Did it work?
It's given me 4 and 5.
You are
Oh,
explaining what, Gowri?
I was trying to get 1 and 8.
You got it?
I got it. I'm trying to tell the procedure using the notation. So start with 1, 2, 3, 4, 5, 6, 7, 8 facing you.
Okay.
Then F1 forward.
F1 forward.
Ah.
1 minute. F1 forward.
So now you will see 1 dash 3, 4, 5 dash 7, 8.
Yes.
Ah.
Okay.
F4 backward.
F4 backward. Okay.
So now you see only 1 underscore 3, 4.
Right. Right.
Yeah, got it.
Yeah. Yeah.
Yeah. Then F3 forward. So you will have 1 underscore and 8.
F3 forward.
Ah.
Then that will hide number 4. Yeah, we want 1 and 8, right?
We want 1 and 8. So now we have
Yeah,
1 underscore and
yeah.
8. So now F2 backward will give us.
Yes.
Yeah.
Sorry. 1 8.
So 1 and 8 is done.
So here I can see some ambiguity in your instructions.
So if we can make 1 8, then we can make 5 4 also, right?
Correct. Yes.
Correct.
So okay. So Gowri, your first fold is F, right? Then you are folding the F4, right?
Correct.
So the way you are folding it, you folded it, and then you are looking at 1 dash 3 4.
Correct.
But I was looking at 5 dash 7 8.
Oh.
No, nothing. I mean, you are looking at the top half. I'm looking at the bottom half.
There is ambiguity. What? Yeah. How you fold, but then how you hold is also required. Yeah. So combination of folds and then look at such and such face. That's still complicated. Okay.
Yeah, I mean.
Acha, so any predictions? Which do you think will be impossible? I think Preeti was saying diagonal ones.
2 7 3 6.
Okay.
Or 1 7.
1 7.
2 7 1 7. If we can try that, then all other are possible. Means
1 7. Let us try. 1 6 1 7. Yeah, if we can do everything with 1, then the others we can sort of extrapolate.
1 7 is possible.
1 7 is possible. Can you describe it?
Let me describe it. F4 fold so that you are looking at 5 6 7 8. Okay. Then fold this and fold 8. So fold this one forward so that now you will have 1 7 8 and fold 8 backwards. So now you have 1 and 7.
Yeah,
Right.
nice.
Yeah. So 1 and 7 is done. If 1 and 7 is done, then 2 and 8 would be similar. So I'll just tick off 2 and 8. 4 and 6 also can be ticked off. Oh, 6 and 7 can be ticked off. Right. 3 and 5 also can be ticked off. It's similar to 1 and 7. Okay. So 1 6, 2 5, 2 7, 3 6, 3 8, 4 7 are the only ones left. And these are all diagonals, which we guess will not be possible. So I also don't have solutions for these. But at the same time, I don't have a solid enough model to say that I've proved that this will not work. I don't have that. So yeah, it looks like these will not be possible. Like as you manipulate it, it's very clear that these diagonals cannot, it cannot work. But I don't have the language to sort of prove it. More questions related to this are, so how many different ways are there to fold it? So how many different folds can we make? How many different ways can we fold it? How many different front and back configurations? How does this extend to, for example, if we had only 2 by 3, would the same results exist or would the results change? So if we just eliminate this, say, so would we still be able to do this and this, but not 1 and 6? We'll still be able to do this, I mean, with the same labels, will we still be able to do 1 and 7, but not 1 and 6? Not 2 and 5, not 2 and 7, not 3 and 6, but others are possible. Will it remain the same? What about if we extend it and let's say we had like 3 by 5 or something? What would change? What would remain the same? So these are some questions. We can either look at these in more detail or pick up something else.
We can look at the counting questions.
If anyone is getting more questions, we can add to this list.
So, can we count how many combinations you've got? So, total number of combinations is going to be 28, right?
These basically.
Which combinations you're talking about?
Oh, I missed one here. 6, 8. 6, 8 also should be doable. Yeah. So combination of front and back faces.
Okay.
So yeah, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7.
Means 1, 2, 1, 1 dash means 2 dash or 1 dash 2 and 1 dash 2 dash.
We won't worry about the dash. It's just the number.
So, we are able to get 22 out of the 28.
Correct.
Right. Okay. So, you can think of the folding as basically just a sequence of this F1, F2, F3.
Yeah.
So you can just, so F1, you can do it in 2 ways. So there's F1 or F1 dash.
Correct.
So you basically have the possibility of 8 possible things.
5 folds. 4 folds. 1, 2, 3, 4.
4 folds, but they can be front or back.
Front or back. So right.
So all of our moves consist of either F1 or F1 dash. So it's effectively you're choosing 4 out of this set.
No, if you've chosen F1, you cannot choose F1 dash.
Correct. Yes. Correct.
So it will be more like 8 times 6 times 4 times 2.
How are you getting this number?
So for the very first fold, you have 8 choices. For the next fold, you don't have 7 choices because by choosing one of them, you have also eliminated its inverse.
Yes, okay.
So 6. Then for the third fold, you have 2 folds which can be done in 2 directions. So 4. Then 1 fold which can be done in 2 directions. So 2.
Okay. But a lot of these will have repetitions. That is, different things will give you the same end result.
Yeah, because we only have 28 possibilities.
Correct.
Of which only some are possible. So a lot of repetitions actually. So 96, 48, 96, right? 96 fours are. Is it 386? 400 minus 384. 400 minus 16. Yeah. Of which there are only 28 unique face pairs.
What is 28?
28 is these.
Peaks, okay.
Uh,
28 are possible so far.
28 are, I mean, not possible. We don't have solution. 28 pairings are there.
Okay, pairings.
Of which we have not got 1, 2, 3, 4, 5, and 6. So we only got 22 so far.
Okay, so I'm thinking
Hmm.
if you, so I'm making a claim that if XY is possible, if XY is possible to be on the outside, then it means it's possible to make X and Y touch each other.
Yes,
Yeah.
touch each other. Is
They
they
share
should
a
come next to each other.
They will share a edge, like when
Ah.
you fold it.
Correct. So
But then 1 and 5, that also they are next to each other. We will consider that also next to each other, right, Ashvi?
so
As
what I'm saying is I can basically fold in such a way that on the outside I'm getting 1 and 5 on both the sides, right? I'm able to get 1 and 5. That means 1 and 5 are on the two sides.
Yeah.
Yeah.
My claim is if this is possible, then it's also possible to fold in such a way that 1 overlaps with 5. That is 1 and 5 touch each other. Touch each other means it's like you can make 1 overlap on 5.
Yes, agree.
Yeah.
One overlap on 5, not that's
Instead of being on the outside faces, we can be on the inside faces of the final thing. So whatever we do blah blah blah. I have got 5 and 8 here now, but I can just fold it ulta to make 5 and 8 touch on the inside. That's what you're saying. Agree.
So now my claim is this is if and only if. That is, if I can't make 2 and 7 touch each other, then it means I can't get 2 and 7 on the outside also.
Oh.
So now I'm trying to show that I can never make 2 overlap with 7.
Wow. Yeah, that is the case because 3 and 6 get in the way. So 2 and 7 can never touch because 3 and 6 get in the way. We only have vertical and horizontal folds. So
I am just thinking how we made 2 and 8 touch each other.
2 and 8, 1 and 7. We could also restate it as if they could be adjacent, right?
Yeah, yes.
Shall we park this and try another activity?
Yeah, okay.
Okay.
So this is actually a branded game called Manifold. Okay, the game is played on, so we need this square line paper for this. So the game is played on a grid of 8 by 8. So if you have this square paper or graph paper. So we need a grid like this. So 1, 2, 3, 4, 5, 6, 7, 8, 8 by 8. We need this 8 by 8 grid. This is the starting point. So of these, some will be colored. So we'll need 2 colors. You can choose any 2 colors. And we are going to first color this. So we all have this 8 by 8 grid now, which is plain paper. Now we're going to color it. So can you color it like this? In any 2 colors. So I have colored my paper the way it was shown in that image. Now the challenge is you have to fold this paper to get a 4 by 4 square. Okay, we need a 4 by 4 square. On one side, it should be one color. On the other side, it should be the other color. So basically, I should fold this in such a way that we can fold in any way. There is no restriction on the folds. So now
diagonal.
Diagonals are also allowed.
No.
So now I have a 4 by 4 square. One side is fully red. Oh, but I failed to get the other side to be blue. we need to fold it in such a way that one side will be fully red, one side will be fully blue.
Oh, you can fold it even diagonally, you said, right?
Yes, any folds are allowed. Any kind of folds are allowed. So this is a branded game, but they have open sourced, few of the challenges, and it's very easy to create our own challenges. And I found it quite enjoyable.
Nice. I have got it.
Yes. Oh, super. I will spotlight you. Yes. Cool.
Wow.
So did you use some diagonal folds?
Yes.
Which folds?
Diagonal folds.
Yeah, I mean, I think you can figure it out. So, yeah, it's possible to.
Okay, so I will share the screen and show the next challenge. So you could use the back of the same paper. I mean,
Coloring configuration.
uh,
And we should end up with what? One side full blue and one side full pink.
correct.
Yeah.
So I have just put together few challenges, and we could then create our own.
Yeah, I found second one.
Oh, okay, wait, I will spotlight you. Stop share. Spotlight. Huh.
I just wrote red, red, red here.
Yes.
Can you see?
Yeah.
And other side blue, blue, blue.
Oh, super. Nice, nice. Yeah.
Gowri, which game is this you said? This is classic game?
It's called Manifold.
So for the second one, we have to try with the same beginning that the diagonals are colored. From that only we have to try.
Exactly. So this is the starting configuration.
Okay. For everything, this is the starting configuration.
Yeah. So for the first challenge, this is the starting configuration, this one.
Okay.
For the second challenge, this is the starting configuration.
Okay.
And the end configuration is always a 4x4 square, which is blue on one side, pink on the other side.
Okay.
We start like this. So
Okay.
this is the second challenge, right?
Okay. Okay.
Now I have to fold it somehow so that I get this colors on one side, this color on the other side.
Okay.
So I could do.
So then what is this next to the number 2 you have written? To the right of it, what is that? To the right of 2, what is that? That is another starting.
That is the third challenge starting position.
Third puzzle. This is
Okay.
four.
Okay. Okay. So, but the end result is always blue square in the one side and pink on the other.
Yeah,
Yes,
4x4 blue square on the front,
Okay.
4x4 pink square at the back.
Okay.
Anyone was able to solve the third one?
Yeah, I got the third.
I'm trying to create my own.
Hey, I got the last one.
Oh, wow. This one.
Oh, nice.
Wow.
All blue, 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 blue.
Oh my God, looks complicated. Oh, nice.
Fine.
Okay, I have created a new challenge.
So, Gowri, this is for your challenge.
Oh, okay. Okay. Cool. This fourth one, I don't know if it's possible.
No, I think there's possibility. I'm able to kind of get close to it.
Oh, okay.
I got the third one.
The fifth one which I got earlier, now I'm not getting.
I am not unwrapping it, I'm keeping it like that. So, can I share?
Okay, Preeti, can you share the third then?
I'll try if it's not clear.
Ah.
The
If
third
you
one.
unfold, it's difficult, Preeti.
Yeah, I'll. So this is the one side, blue, and this is the other one. So I'll just open it. I think so. This Actually, so I had to fold it.
So that long sleeve, this
So I folded it like this into half. Then I did this. So I folded it into half, and then I did it this, and I folded it down, and I brought this together. I don't know if that makes sense.
Yeah.
So if I did this, and then where it is, yeah. I don't know. Yeah, I think now I'm getting it. Basically, what I tried to do was get these two into a square, and then the remaining, if I folded it, this corner came there.
I got fourth one by some very contrived folds. So pencil and this black thing are the two colors. Okay. Yeah. Yeah. Basically, I did something like this to get these two together. So now these two are together. Now I have to fold the rest of it around this to make it work. The key for me was getting these two. Now this can be folded like this so that this is on one side, this is on one side. So once I got this, the rest fell into place.
Show me again the first step.
So I wanted to get this and this together. So along this diagonal, I did this. Then this goes off into 3D mode. It's like this now. It's become like a corner of a cube. But later on, it works out.
Yeah. Got it. Yeah.
Yes.
Okay. Thank you all.
Thank you.